In this demonstration, I'm going to demonstrate how you can use a function-based index to conduct a case-insensitive search. Right now, I have an index created on the last name column of the students table. But as we see here, this is just a normal index, not a function-based index at this time. So I'm going to use this query that we have from the slides, and I'll execute this query and we'll see that we get 9 rows back. Now the issue here is that we really should have got 11 rows back because we have 2 additional rows in the database with the last name of McNeil, but those are stored in a different case. And I can demonstrate that if I change my query to use a lowercase n in the value in my where clause, and now we see those other 2 rows. Of course, the problem is with this query, we're not seeing the original 9 rows. And so the bigger problem is whatever our user types in, those are only the rows that we're going to get back. We're not going to get back all of the rows. And this is a problem because if the user doesn't know the exact case, they're going to be confused by the results. Now the good news with this query is that if I execute it using the auto trace capability, we see that we are using our index and we have a very low cost, a cost of 3. So our performance is good. It's just the problem with this query is that it returns the wrong answer most of the time. So let's fix this query, and the first fix that we're going to apply is one that's commonly tried, and that's to use the upper function in the where clause, both on the column name and on the value that we're searching for. And now we execute this query and we see that we're getting 11 rows back, and this is the right answer. So from a functional point of view, we've solved our problem. The issue here is that when we use the auto trace feature to execute our query, we see that we're no longer using the index that we have on the last name column. We're now doing a full table scan. The reason why is because of the function in the where clause. By adding the upper function to the where clause, Oracle is no longer able to use the index that we have on this table, which is just a normal index. So let's go ahead and drop this index. And we'll recreate this index as a function-based index. And now I want to gather stats on the table to make sure the Oracle Optimizer has the most up-to-date information about the index. Technically, from Oracle 10G on, you're not supposed to need to do this anymore. There are times, though, where I've seen some odd results by not regathering stats on the table, so we'll just be safe here and make sure that stats are up to date. Okay, so we're finished with that, and so let's go ahead and get rid of this to clean up our window. And now we'll rerun our query up here that's using the upper function. And so we see that we still get the right answer back, which is good. And now we'll execute this query with auto trace. And we see we're using an index now to execute this query, and that's the function-based index that we just created. So this is very positive. We're now able to conduct a search that's case-insensitive, and thanks to our function-based index, we're able to use an index operation for this query. So we're getting good performance and we're getting the right answers when running this query. And this is really what function-based indexes provide, is the ability to build this index over this computed value in a table, and then you can query that table on that computed value, but still use an efficient index operation and not have Oracle using a full table scan, which of course is much less efficient.